Bentar, aku mau. Oke, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, students. How are you? Fine too, thank you. So today we're gonna study vector. And in this material, we will be discuss about definition of vector quantity, the vector addition operation, and also the vector multiplication operation. Let's start from what is vector. But before that, I want to ask you guys, any lamp that turn on in this class right now? Lamp that turn on in this class right now? 3, 4. It's for lamp that's turned on in the class right now. Next question. Mahendra. How far is your home to UNES? Okay, it's 30 kilometers. And the next is, how do I get to your house from UNES?
You can follow
The direction? North, south, east, west? Okay, so that's how I can fully achieve what I want if I asking about where is the direction from UNES to your house. How do I get to UNES how do I get from UNES to your house, like that? The information that I needed is the magnitude of the direction, the how far from UNES to your home, and also the direction, which direction I should go from UNES to your home. Is it east or is it west, north or south, like that? Okay, that's about vector quantities. It's basically some quantities that besides magnitude, it also have direction. Maybe to increase your understanding about vector material, I will introduce you to a game that actually using vectors in it. Okay. So there is a game that called Mobile Legends. It has a character named Fanny. Fanny has a skill to launch cable and follow the cable from its start to from the tip of the cable to the point that the cable is go, like that. And this concept of the hero using vector as the concept. So where's the vector? It's in here. As you can see, this hero Fanny, it can move further if it's only using one cable. It will just follow the cable direction. But if it's using two cables, it could go even further. So as we can see in the video, the force from the cable is equal each other. So there is no force from the cable as a variable. So it's constant. And what if, and also the length of the rope is not part of the factors. So the force is equal. And here we can see that the angle of the cable is small. It makes the funny move even further. And what if the angle of the cable is smaller? It will make funny is move shorter like that. And by using to analyze these heroes in Mobile Legends, we're gonna use vector resultant. But before that, the vector addition operation is consists graphical and also analytical. Let's start from graphical method. Graphical method is method that calculating vector quantities by describing the addition of two or more vector based on their value and direction and forming a flat plane. And to determine the result of vector addition using graphical method, we need a measuring tools, for example, a ruler and also a protractor for finding the angle like that. In the graphical method, it consists polygon method and also parallelogram method. Let's go with polygon method. First, I wanna draw the example of polygon method. So there, the first is polygon method. So to know how we know the resultant of a vector by using polygon method, first we need to set a scale. In this example, I'm using this ruler as a scale. It's 1 centimeter. And we need to scale it one per one as a scale. So the magnitude of the force is exactly just like the length of this ruler. And the next is we need to drawing the F1 first, then draw the base or capture plane of the vector F2 coincides with the end of the vector F1. And if the numbers of vector added more up form 2, so base vector next squeeze with vector previously until 1. So we need to redraw this only vector. We don't need to draw the thing again, just draw the vector. So this is the F1 and this is the F2. And there is an angle theta. From the F1, by using ruler, we know that this is 25 centimeters. So because this is a forces, so it's 25 Newton. And for the second vector, second forces, it is 35 Newton. And the next information that we need to find is the angle of the second vector between the F2 and also the x x coordinates. To know the angle, we using this protractor. Put the protractor in the connection point of F1 and also x coordinates. And we can get 36 degree. So we need to redraw all the information that we already got. It is F1 25 Newton, F2 35 Newton, and with the degree 36 degree, with the angle 36 degree. Redraw the vector. The second force. No, first we need to with the angle of 36 degree. Actually, it's right here. Thirty-five. And for the last step, we draw the resultant vector by drawing an arrow from the base of F1 to the tip of the F2. And we get the resultant of this example by using ruler. We get get to know that the resultant of the force is 57 Newton. So that's how we conduct the factor. We adding the factor by using polygon method. And the next method is by using parallelogram. If in the polygon method we make it as the triangle, in the parallelogram method, of course, we using the first factor f1 and the second factor f2 as the parallelogram. We know that to do the parallelogram, we need to draw the f1 more formally than picture the factor f2 with base factor f1 merges with the base factor of f2. If in the polygon method we merge the top of the f1 with the base of the f2, but in here we merge both of the base of factor 1 and also factor 2. By degree, it's 36 degree. $35 centimeters. It's 36. Okay, then because it's parallelogram, we need to make another part of this parallelogram the same with f1 and also f2. And for this part, and for the last step, we make line arrow shape diagonal with the base merge and the base and the connection between the new factor that we made, the tip of the two factor that we make based on the two factor before. And by measuring with the ruler, we also get that the VR is 55 Newton, same. No, actually this one is 57 and this one is 55. So the actuality is 2 centimeters, I think, yes. And that's for the addition operation of parallelogram method. And next we will go to the multiplication operation. The first one is scalar multiplication. In the scalar multiplication, when a factor is multiplied by a scalar number, a new factor is obtained. For example, in here there is vector A and also vector B, and the K is scalar. So B is equal to K times by A. The magnitude of vector B is K times the magnitude of A, while the direction of vector B is the same as the direction of vector A. So if K is positive and the oppositely K is negative like that. In physics, we can find this kind of operation. For example, F is equal to Q times A, where Q is the electric charges. So it can be positive and also negative. If it's positive, it's go to the positive coordinates, X positive or Y, Z positive. And if it's negative, so the vector will go to the opposite direction. And the next one is multiplication between vector and vector. It's concluding dot product and also cross product. For the dot product is multiplication that called scalar product because when we both times between multiply between both vector, just in here there is vector A times vector 2, vector A dot vector 2, vector B. It gonna make the magnitude of its multiplication is scalar quantities like that. Because of that, this product is called dot product. A dot B can be defined by drawing both vectors with their origins at the same point. Then look for the vector components that are parallel between the two vector A dot vector B, like that. In this picture, if C is dot product between A and B, it means C is equal to AB cosinus theta because we need to vector B to same coordinates, same direction with vector A, so it times by cosinus theta. And if you operate this kind of multiplication, this dot product into the vector notation, that as we know, the vector notation is, we put AJ and also K. If both I, J, and also K is dot by the same vector notation, it will equal to 1. Oppositely, if it's dot product by different notation, it gonna equal to 0. For example of this dot product multiplication, it's work. Work is equal to force times by the direction, the F times by S. Okay, the last is cross product. So the cross product is known as vector product. When we cross both vector, it equal to vector also, like that. As we can see in here, same with the dot product. If we cross product the notation of the vector, as in the slide, it is same notation crossing by the same notation also, it gonna equal to 0. But if I cross by J, it gonna equal to K. If J cross K, it's gonna equal to I. And if K cross I, it's gonna equal to J. And the example of this cross product, it is torque. It equal to R times by F. And also F, it is magnetic forces, it is Lorentz law. It is F is equal to QV cross B. Okay, so I have student worksheet. We will conducting some experiments. So I will divide you guys into two groups. Okay, so the assignment is you guys need to prepare the measure item, and in here we have a factor A with 12 centimeter, factor B with 5 centimeters. In the factor A, it makes angle 15 degrees with the x coordinates, and for the factor B, it is making angle 75 degrees with the x negative. So what I want you guys to do is, first I want you guys to find the factor resultant by using a FAT simulation, and also the second one is by manually using measure items. So for the first group, I think it is Wahid and also Rahmanisa, and the second group is Rosa with Mahen. In here, I have two ruler. You guys can do the manual, do manually to find the factor resultant. And for the simulation, I will borrow you my laptop, and also we can use. Okay. Okay, please go to the front of the class to find the factor resultant manually by using measure items. So I will ask you guys to using the parallelogram method to manually find the resultant factor. Okay, time is yours. We still have 15 minutes. I think it's 20 to 15 minutes. We still have so much time. Just doing the practicum, please. In here. Here is the yes, this is the worksheet. So it is 12 centimeters and also x centimeters, because the other ruler is, I think it's have bigger scale. I think you can multiply it, I think times by 5, 60 with 48, or 48 with 32. Twelve and 8. 60, it means with 40. For the factor A, it is making angle 15 degree with x positive. And for the second factor, it is x centimeters, making 75 degree with the x negative coordinates. X negatif berarti 75. Lima 12 parallelogram. Do it conducted like this. Redraw the base of both vector is already merged. You need to draw the equal factor with B and the equal factor with A, and the direction is like this. So the base of second factor that equal to factor A is merged with the tip of the F2, like that. So there is the factor A and here's the factor B. To conduct this addition by parallelogram, we need to draw another factor equal with this first factor. And the other one. It's 15 degrees. This one is 75. So the resultant, yes, we make. And there we have it. It is, I think it's around 14. Measure it to find the resultant by using the ruler. How much it is? It should be around. I think it's the same scale. 13.
Yes, 13.
The FR is 13 centimeter. Okay, thank you, group 1 and group 2. And for the other measuring, we will using PET. Please, Wahid and also Rosa come to front to using PET simulation to find the resultant vector with the same case. 15 degrees with x positive coordinates. The length is 12 centimeter.
Why do you have to-
15 degree. For the second vector, it is x centimeters and making angle 75 degrees. 8 centimeters. Using parallelogram method, please find the resultant of the vector. Nah, bikin ulang. Oh, ya, betul. Ya. Gila. I'm sorry. Okay. So by using fat, we get around 13.5. So with this equation to find the factor, I will do the equation by using resultant is equal to first factor squared plus second factor squared sine theta. And here we can get cosine of this angle. So it is 90, 60 with 15. Twenty-five and 15 degrees. So it's 90. Cosinus 90 is, and we're using sines. Cosine of alpha. It's 15. Okay, so it should be or 108. So I think there is almost same with both manually using measurement and by using fat and using equation. Okay, the times is up. I think that's all for our meeting this afternoon. Sorry for any mistake that I made all of this hour. Please, I'll see you again on the next meeting. Wassalamualaikum warahmatullahi wabarakatuh.